Morning, Algebra 2. Today is Thursday, March the 26th, and we are going to begin our unit on logarithms today. So this will be titled Introduction to Logarithms. Okay, I will save these as a PDF for you. So if you want to just watch me work through this right now, you can come back later and copy the notes through. All right, so what is a logarithm? The inverse of an exponential function, the inverse of an exponential function is a logarithmic function. The inverse of an exponential function is a logarithmic function. Exponents and logs are very closely related to each other. If I gave you the exponential equation 3 raised to the x equals 27, or the exponential equation 3 raised to the x equals 81. Well, just from what you've memorized in our last unit, you should recognize that, 3 cubed is 27, 3 to the 4th is 81, so I can solve those two exponential equations because I know my powers of 3. However, if what I gave you was 3 raised to the x equals 52, we don't have a power for that. We know it's got to be somewhere in between 3 and 4, but it's going to be some kind of a decimal. So if it's not an exact power, we are going to have to use logarithms to solve for this. All right, but before we start solving any kind of exponential or logarithmic equations, we need to understand the difference between exponential form and logarithmic form. These two are very closely related, and you need to be sure that you understand the difference. So we have exponential form, and we have logarithmic form. You need to be sure and memorize this relationship between these two. We'll be using it throughout the entire unit. It's very important that you memorize these two things. Now, you are very familiar with exponential. You are used to working with exponential. Like you've got a base raised to an exponent, and it equals some number. I might have 5 cubed equals 125. I might have 27 to the 1/3 equals 3. Remember that rational exponents are the same thing as roots. 27 to the 1/3 is the same thing as the cube root of 27. I might also just see variables. A raised to the b is equal to c. Okay, that is what exponential form looks like. Logarithmic form looks like the log of the base of the number equals the exponent. Log base number equals exponent. Just like your exponent up here is a superscript, a little bitty number up there to the right, your base right here is what we call a subscript. It's going to be a little bitty number down below. 5 cubed equals 125 would be written log base 5 of 125 equals 3. Or log base 27 of 3 equals 1/3. Or when you really have to have it memorized is with variables, log base a of c is equal to b. A lot of times people will think about there's a little spiral kind of action, let's say. The base raised to the exponent equals the number. The log of the base of the number equals the exponent. If you're trying to switch something in exponential form into log form, it goes this direction. Or if you're trying to switch something from log form into exponential form, it is going to go this direction. So if you can memorize those two patterns, or just think about this little circular motion, you will have to be writing back and forth between log and exponential form. You will see that quite often. One thing we need to remember is that we can have all different types of exponents, okay? Exponents can be, they might be whole numbers. Okay, so if I have an exponent that is a whole number, basically whatever my base is becoming a larger number. 3 to the 4th equals 81. 5 to the 3rd equals 125. 1 to the 5th equals 1. Well, 1 raised to anything is always going to be 1. We may also have rational numbers or fractions as exponents. Remember at the beginning where I wrote 27 to the 1/3. 1/3 is a fraction. So if I have 81 raised to the 1/2, well, that's 9, because I mean, that really just means the square root of 81. If I have 64 to the 1/3, that would be 4, because that's really just the cube root of 64. Likewise, sometimes you might see something like 125 to the 2/3. Well, I mean, what does that mean? That really means the cubed root of 125 squared, which the cubed root of 125 is 5, and then 5 squared equals 25. Okay, so again, we can have exponents that are whole numbers. The numbers are becoming larger. We can have exponents that are fractions. They're becoming smaller. You might see negative exponents. All right, so if you have a negative exponent, if you see something like 7 to the -2, remember that negative is going to go down in the denominator, so that's really like 1/49. Move it to the denominator, the exponent becomes positive, so that would become 1/49. If you have some kind of a fraction, let's say 1/5 raised to the -2, then that 5 is truly coming up into the numerator to be 5 squared, and that would be 25. The last type of exponent we might see is a zero exponent. Okay, with a zero exponent, remember anything to the 0 always equals 1, no matter how large or how small. 20 to the 0 would be 1. 10,000 raised to the 0 would equal 1. And the reason that is because if you think about your exponent rules, like if I have x to the fifth over x to the fifth, our rules for dividing exponents tell us to subtract. So if I'm subtracting 5 minus 5, that's going to be x to the 0. Well, but we also know that anything over itself equals 1. So that's why when you subtract and get a 0, it equals a 1. All right, so to start off with, we are going to be evaluating logarithms. This is where you've got to be very familiar with your exponents and your powers. And basically, you're finding the value of the log. This is expected to be done without a calculator, which I know we're not in the classroom and I can't watch everything you're doing. However, you need to know these powers and you need to expect to be doing this without a calculator. You kind of have to figure it out. All right, so if you're going to evaluate, the first thing you're going to do is set the expression equal to x. Okay, so the log expression they give you, we're going to set equal to x. And then we are going to rewrite it into exponential form. Rewrite into exponential form. It'll be given to you in log form. And you're going to switch it around to exponential form. And then you're just going to, solve what that is. You should be able to recognize what type of exponent it would be. All righty, so our first example. I have log base 2 of 32. Okay, so this is what the problem will look like when we give it to you and we ask you to evaluate it, which again, that's just a fancy word for finding the value of it. We are going to set it equal to x. Then we're going to rewrite it in exponential form. If you need to use your little arrows, that's fine. So 2 raised to the x equals 32. And then truly at this point, you should be able to recognize, that 32 is a power of 2 and that 2 raised to the 5th equals 32. So x would equal 5. Right here, we've got a smaller number, 2, going to a larger number, 32. So that has a whole number exponent. All right, a second example. Let's say we've got log base 25 of 5. So just the same, you are going to set it equal to x, rewrite it in exponential form. 25 raised to the x is equal to 5. And then you've got to figure out, 25 raised to what equals 5? Well, it's a larger number becoming a smaller number. Sometimes it's easier to start over here and say, well, how does 5 become 25? 5 squared becomes 25. So that means that 25 to the 1/2 would become 5. Because remember, the square root of 25 equals 5. So a radical, the square root, is a 1/2 exponent. So like here, I've got the larger number 25 becoming a smaller number 5. So that is going to be some type of rational exponent. Rational is just a fancy word for a fraction. All right, so the first one, again, just to review, a smaller number becoming larger, I've got a whole number exponent. A larger number becoming smaller, I have a fractional exponent. If they gave me log base 3 of 1/9, and they asked me to evaluate that, Again, set it equal to x. I'm going to rewrite it in exponential form. 3 raised to the x equals 1/9. And then, if I'm going here from a whole number to a fraction, let me give you just a little bit more room. If I'm going from a whole number to a fraction, or vice versa, if I'm going from a fraction back to a whole number, this is going to be some kind of a negative exponent. So once I recognize that I've got to have a negative exponent, I'm really just thinking, how does 3 become 9? Well, 3 squared is 9, so x is going to be the negative 2. The negative makes it move to the denominator, and the 2 squares the 3 to become the 9. All right, we're going to look at 2 more examples. Log base 65 of 1. Set this equal to x. Rewrite it in exponential form. 65 raised to the x equals 1. Well, what did we say? Anything raised to this exponent always equals 1, and that would be our 0 exponent. Okay, you've got to be real careful to remember that. Anything raised to the 0 always equals 1. Alrighty, one more for our last example, example number 5. We are looking at log base 25 of 125. All right, so I'm going to set that equal to x. I'm going to rewrite it into exponential form from, if it has the word log, this is log form. Exponential form, if you need to do your arrows, that's fine. I've got 25 raised to the x equals 125. And then now, 25 squared is 625. So, this isn't 1 and this isn't 2. So I've got to figure out what it is. A lot of times when you see something like this, you can rewrite these as the same base. Okay, you should at least recognize from the powers you memorize that these are both powers of 5. So if I rewrite them as the same base, 25 becomes 5 squared raised to the x. 125 becomes 5 cubed. Power raised to a power here, multiply, so I've got 5 to the 2x equals 5 to the 3rd. And then, if they're both base 5s, then these two things have to be equal to each other. So from that point, I can just set the exponents equal. 2x equals 3. Divide by 2. And I get that x equals 3 halves. Okay, so 25 to the 3 halves does equal 125, because this means you're taking the square root of 25, and then you are cubing it. All right, I hope y'all have a great Thursday. I will post these notes also for you to copy down, and I will have the assignment on the blog. Take care.